Good day everyone, this is Engineer Aljan Michael G. Sabak and I welcome you to 7th session on the study of Earth science. Last session we have traveled towards the history and realms of astronomy. I hope that you have learned something about it and you have enjoyed and noted the important things that had happened in the past years. Today, in this session, let's dig deeper towards our future as humans residing on our own planet Earth. Let me ask you with some simple questions first before we go to our main topic. First is, what is the first thing you touch when you wake up? Probably you will check your phone for updates in your Facebook or Twitter account. Or you'll just go out of bed to prepare yourself for school. Maybe you'll go outside to breathe some fresh air or even do the cooking and prepare breakfast for your family. After you've done preparing, you will travel to school by bus or by using your bicycle or just ride a public utility vehicle, then do the normal things a student would do at school. More or less all of you have the same routine every day, from the time you wake up and the time you go to sleep. Living a life in the present time is harder than we thought because there are changes that will happen every now and then in your own lives. Now, imagine what it feels like to live in a simple life. Be it that this life is like living in a faraway land that only you and yourself is in it. Imagine you live in this place where there's no electricity, there's no vehicle in sight, no cell phones, and no internet. Your source will be by hunting of wild animals and picking of any kind of herbs you think that is edible. And there's no seasoning or anything else that can make a food tasty. Everything that you need is within Mother Nature. Would you live with this? Or do you prefer your life now? Which is better? How will you react with this environment? Will your life still be as easy as you experience today? Your answer will differ from one another since every one of us has its own perspective of life. And this is a sign that we humans are adapting and evolving to survive. The society has been dramatically changed with the evolution of technology. Before the advent of modern technology, life was burdensome and everyday chores consumed too much of our time. Immense opportunities are being provided by technologies which play an important role in human life. The access to education, medicine, industry, transportation, has been simplified due to modern technology, and we know that it is evolving. Due to the convenience and efficiency provided by it, our lives have improved significantly. No one can escape from the absolute need of technology in our daily life. Every one of us is so dependent on technology that we cannot do without them. Technology has a very big role in most aspects of our lives. In other words, it answers all of our problems. The importance of technology is aiming for comfort of use in whichever form it is. It always direct for easiness in life. Now, the question is, how did this technology started? What is its origin? What is the source of this everything? Yes, you're right. The source of everything is the gift of nature to us humans. These are the raw materials that we need in order to upgrade ourselves. These are the minerals. These are the source that made everything happen. From the spoon and fork that you are using for dinner to the gadgets that you are using. From the houses that were built to the tools that are designated for it. Almost everything in your home comes from the mineral realm. Earth's crust is composed of about 3,000 minerals. Minerals play important roles in forming rocks and in shaping Earth's surface. A select few have helped shape civilization. For example, great progress in prehistory was made when early humans began making tools from iron. This unit will start with an overview of the study of minerals, and that is mineralogy, since minerals are the building blocks of rocks that are used not only today but throughout history. Human beings have used these materials for both practical use and also with aesthetic purposes, e.g. decorations. These minerals have also been used in technology, used in our gadgets and computers. Look around your classroom. The metal in your desk, the graphite in your pencil, and the glass in the windows are just 3 examples of how modern humans use products made from minerals. Minerals are not only important for their many uses, but also as the building blocks of rocks. Minerals are all around us. the graphite in your pencil, the salt on your table, the plaster on your walls, and the trace amounts of gold in your computer. Minerals can be found in a wide variety of consumer products including paper, medicine, processed foods, cosmetics, electronic devices, and many more. And of course, everything made of metal is also derived from minerals. These are the so-called everything that made things easy. Without minerals we cannot achieve the easiness of life we experience today. Now, I will present you the top 10 minerals for the modern world. 1. Is copper. That is the most vital mineral since it has very wide usage. Most copper is used in electrical equipment such as wiring and motors. This is because it conducts both heat and electricity very well, and can be drawn into wires. It also has uses in construction, for example roofing and plumbing, and industrial machinery. Platinum also plays a critical part in electrical boards that are used to create gadgets like smartphones and smart televisions. Iron on the other hand is a major component in structures. It is used to manufacture steel and also used in civil engineering like reinforced concrete. Iron is used to make alloy steels like carbon steels with additives such as nickel and chromium. Silver is important for manufacturing. It is used for jewelry and silver tableware, where appearance is important. Silver is used to make mirrors, as it is the best reflector of visible light known, although it does tarnish with time. It is also used in dental alloys, solder and brazing alloys, electrical contacts and batteries. Gold is known for its high value, though it can be used for medicinal applications. Cobalt has a growing demand for magnets. It is used in alloys for aircraft engine parts and in alloys with corrosion wear-resistant uses. Cobalt is widely used in batteries and in electroplating. Cobalt salts are used to impart blue and green colors in glass and ceramics. Aluminum makes metal parts cheap but durable. It is used in a huge variety of products including cans, foils, kitchen utensils, window frames. Lithium is widely used for efficient batteries and zinc is vital due to its resistance to corrosion. Potash also is a component of fertilizers that are widely used around the globe. We use minerals in almost every aspect of our lives. We live in a mineralized house, we use gasoline, we use graphite for pencils and minerals for jewelry. Without minerals, our lives are different. In addition to daily use, we can also use minerals to date quite accurately with the earth. You never thought of how much minerals could really be used to make a house. The metals and minerals we rely on in our everyday life is staggering. If you really take a moment to think about it, look around to observe the objects you are surrounded by which are not manufactured by plant-based resources. From the cement you walk onto the screen you are reading, our world and our way of life depends on these products since it supplies the modern world foundations. The importance of minerals travels in all means and aspects since it is vital in these different industries. Food industry, transportation industry, electricity, technology. These are some of the few that minerals is an utmost need for these industry to progress. Now, let me ask you from your perspective. What is a mineral? What comes into your mind when you hear it? You might think that it is the mineral water that we use to drink every day, right? Or the minerals that you need in your body to help you grow. Or the things that you have been eating that supplies you these minerals in your body. The term mineral is used in several different ways. For example, dietitians use the term mineral to refer to nutritional elements such as calcium, iron, or sodium. The mining industry typically uses the word mineral to refer to anything extracted from earth, such as coal, iron ore, or sand and gravel. Some say that minerals are just pretty gemstones that are used in jewelries. Some say that minerals are so rare that it has a high market value. But what really is a mineral? Before I will reveal the definition of it, I will tell you first how minerals are formed so that you can visualize the process on how it is made. Mineral formation. There are various processes that a mineral can form. Mineralogy is the science for it. It tackles the chemistry, atomic structure, physical properties and genesis of minerals. Let's discuss it one by one. First as we have the process of magma crystallization. Many minerals start out in liquids that are hot enough to melt rocks. Molten material that forms and accumulates below Earth's surface is called magma. Magma is melted rock inside Earth, a molten mixture of substances that can be hotter than 1000 degrees Celsius. Magma cools slowly inside Earth, which gives mineral crystals time to grow large enough to be seen clearly. Magma is less dense than the surrounding solid rock, so it can rise upward into cooler layers of Earth's interior. Here, the magma cools and crystallizes. Next as we have, ion solution precipitation. Minerals are often dissolved in water and crystallizes when the solution in which they are dissolved evaporates. For example, the salts that are dissolved in ocean water. Minerals that form from the evaporation of liquid are called evaporates, just like that in the picture. Third, we have the process of saturated solution or cooling by liquids. When a liquid becomes full of a dissolved substance and it can dissolve no more of that substance, the liquid is saturated. If the solution then becomes overfilled, it is called supersaturated and conditions are right for minerals to form. At this point, individual atoms bond together and mineral crystals precipitate, which means that they form into solids from the solution. Magma heats nearby underground water, which reacts with the rocks around it to pick up dissolved particles. As the water flows through open spaces in the rock and cools, it deposits solid minerals. The mineral deposits that form when a mineral fills cracks in rocks are called veins. Lastly, we have metamorphism. This is the formation of new minerals directly from the elements within existing minerals under conditions of elevated temperature and pressure. The best example for this is a diamond, the hardest mineral. Now, that you have an overview of how minerals are made and the formation of which they are processed. What do you think is a mineral? How can we define a mineral? How do we know if a material is a mineral or not? How can we distinguish it from other things that we see every day? Earth materials that are classified as minerals exhibit the following characteristics and we define them by these terms. Since all minerals have all these characteristics. A mineral is a homogeneous solid. A mineral is naturally occurring. A mineral is crystalline. A mineral is inorganic. A mineral has its own definite chemical definition. Altogether, a mineral is being defined as a naturally occurring, inorganic, crystalline substance that has a definite chemical composition and a homogeneous solid structure. Let's discuss these definitions one by one on the next slides. Minerals are naturally occurring. Minerals are naturally occurring, meaning that they are formed by natural geologic processes. They are not man-made and they are not made from synthetic materials. Synthetic diamonds, steel and other substances developed in laboratories are not minerals. Minerals are inorganic. Inorganic means that minerals have not been ever alive in the first place. It does not consist of or derive from living matter. Involving neither organic life nor the products created from or by organic life. Minerals are crystalline. The atoms in minerals are arranged in regular geometric patterns that are repeated. This regular pattern results in the formation of a crystal, thus it looks like a rock candy. Minerals have definite chemical composition. Each type of mineral has a chemical composition unique to that mineral, and they can be expressed by a specific chemical formula. Means that all occurrences of that mineral have a chemical composition that varies within a specific limited range, and the atoms that make up the mineral must occur in specific ratios. For example, salt is sodium chloride and dolomite on the image is calcium magnesium carbonate. Minerals are homogeneous solids. They are neither liquid nor gas, and every mineral has its own definite shape and volume. A mineral must be chemically and physically uniform down to the atomic level. This homogeneity means that the mineral will have absolutely predictable physical properties including hardness, density, and streak. We can easily memorize the definition of minerals with this mnemonic. N I C D S. N stands for naturally occurring. I stands for inorganic. C stands for crystalline. D stands for definite chemical composition. S stands for homogeneous solid. And say it loudly. Now I can define minerals. In nature there are many minerals. Around 2,000 species are known. Some of them are very rare, while some others are very popular. Let's try to have a checkpoint quiz. Use the mnemonics to define a mineral. If one of the definition is absent, then that material is a not mineral. From the three images, which is a mineral? Jade is mineral while the shell in our teeth is not, since these two comes from an organism. Now let's try another one. Now which of the three is not a mineral? The obsidian in the middle and the pearl is not a mineral, since obsidian is considered as an amorphous solid, meaning it does not have a crystalline structure, and when we look at it, iron resembles a glass. While the pearl comes from an organism, therefore it is not considered a mineral. The snowflake on the other is a mineral, since it has all the definitions of a mineral. How about between a fossilized dinosaur and an amber? Which is a mineral? Both are not minerals, since the two are fossilized remains of an organism. One of which comes from the dinosaur and one is from a tree sap. Mineralogists are scientists who study minerals. One of the things mineralogists must do is identify and categorize minerals. While a mineralogist might use a high-powered microscope to identify some minerals, most are recognizable using physical properties. These are physical properties that can distinguish a mineral. These are being used on how to identify each and every mineral that is found on Earth. We have habit, breakage, streak, transparency, color, tenacity, luster, and lastly hardness. Each of which has its own characteristics that can determine the name of the mineral itself. Some minerals form such distinct crystal shapes that they are immediately recognizable. It is the term used to describe the general shape of a mineral. This is used to describe the general shape of a mineral or its tendency to repeatedly grow into characteristic shapes. Their shapes are influenced by their atomic structure or also influences by the environment of crystal growth. Crystal habit or shape are classified into two types. One is we have individual crystals, and the other one is we have aggregate crystals. Within the individual crystals, the minerals in this type can be cubic, tabular, prismatic, octahedral, acicular, equant or bladed. Cubic individual crystals are cube-like. Octahedral ones have 8 sides. Tabular are almost tab-like, the can almost resemble as tables, or rectangular in shape. Equant on the other hand have sides that are roughly equal. Acicular-shaped individual crystals have pointy thing shapes. Prismatic are prism-like. Blades crystals almost resemble as a knife. Within the aggregated crystals, we have the following druzy: radiated, globular, reticulated, botryoidal, dendritic, stellate and fibrous. Dendritic crystals are root-like or tree-like. Radiated crystals have shapes that radiates outward from a central point. Reticulated crystals resemble a network-like structure. Fibrous crystals are fiber-like. Druzy crystal shapes have aggregate of small tiny crystals. Stellate crystals have star-like shapes. Globular resembles grapes and botryoidal are aggregate of rounded masses. Now let's try to have a short quiz. Just determine the shape of the following minerals. Which one is radiated and which one is bladed? The left one is radiated while the right one is a bladed shape mineral. Which one is cubic and which one is an equant? The left one is cubic while the other one is equant in shape. Which one is prismatic and which one is acicular? The left one is acicular and the right one is prismatic. Which one is dendritic and which one is reticulated? The left one is dendritic and the right one is reticulated. Which one is tabular and which one is stellate? The left one is a tabular one and the right is a stellate mineral. The next property is we have luster. Luster describes how shiny the mineral is. It refers to the way of light is reflected from a mineral surface. Some have metallic surface such as gold, silver and copper. Others described as non-metallic like vitreous or glassy, pearly, silky, resinous and earthy or dull. This is how metallic and non-metallic lustered minerals differ from each other. Metallic minerals are shiny and more metal-like while non-metallic minerals are dull and are non-shiny. These are examples of metallic and non-metallic lusters. Non-metallic lusters include pearly, vitreous or glassy, resinous, silky, greasy, adamantine, dull and waxy. Now let's try to have a short quiz. Just determine the luster of the following minerals. Which of the following is metallic and which of the following is non-metallic? The metallic one is the one that is in the middle portion while the bottom two are non-metallic. Now what kind of non-metallic luster are those two minerals at the bottom? The left one has a glassy or vitreous non-metallic luster while the right one is a waxy one. Another optical property used in the identification of minerals is the ability to transmit light, and that is transparency. We have 3 types of transparency and it includes the following. Opaque is when no light is being transmitted. Translucent is when light, but not an image, is transmitted through a mineral sample. Transparent is when both light and an image are visible through the sample. Color is the least reliable trait because it can be misleading since color can vary when exposed to moisture, temperature and weathering. Color is sometimes caused by the presence of trace elements or compounds within a mineral. Generally the most conspicuous characteristic of any mineral. Now let's try to have a short quiz. Just determine the mineral through its color. Which of the following is a quartz mineral? You might think one of each of the samples, but all of these are actually quartz mineral. Each has its own color because of different impurities. Which of the following is a beryl mineral? Same with quartz, all of these samples are actually beryl minerals, but the most common color of a beryl is green, but some of its color is derived with different impurities that it has undergone. Yes, you might notice that color is not reliable in mineral identification. Just like people, outside color does not tell you much about the important characteristic of a person. Same case with minerals. Streak is a property of a mineral that refers to the color of the powdered mineral. The sample is rubbed across a piece of unglazed porcelain or streak plate. This is the color of a mineral when it is broken up and powdered. A mineral rubbed across an unglazed porcelain plate will sometimes leave a colored powdered streak on the surface. The streak of a nonmetallic mineral is usually white. And remember that a mineral may appear one color and then produces a streak with different color. Breakage, on the other hand, is the tendency of minerals to break along planes of weak bonding. It is described by the number of planes exhibited and the angles at which they meet. There are two types of breakages. Cleavage and fracture. Cleavage is when a mineral that splits relatively easily and evenly along one or more flat planes. While fracture does not exhibit cleavage or said to fracture when broken. Some break like glass, some into splinters or fiber. Now let's try to have a short quiz. Just determine the breakage of the following minerals. Which of the following minerals has a cleavage and a fractured breakage? Number 1 has a cleavage property. Number 2 has a fractured breakage. Number 3 has also a fractured breakage, and the last one resembles more of a cleavage pattern since we can see smooth planes on its breakage plane. The next property is we have tenacity. This describes a mineral's resistance to breaking, bending, cutting, or other forms of deformation. Nonmetallic minerals, such as quartz and halite, tend to be brittle and fracture or exhibit cleavage when struck. By contrast, native metals such as copper and gold are malleable, and can be hammered into different shapes. In addition, minerals, including gypsum and talc, that can be cut into thin shavings are described as sectile. Still others, notably the micas, are elastic and will bend and snap back to their original shape after stress is released, and other minerals are ductile that deform readily under stress. Hardness is the property of a mineral that has a resistance to being scratched. The harder ones are difficult to scratch, the softer ones are less resistant to scratches. Friedrich Moe, a German mineralogist, prepared a scale of hardness with a number of 1 to 10 in the increasing hardness. This is the Mohs hardness scale, with the softest mineral as talc and the hardest as diamond. These are some special properties of minerals. Double refraction occurs when a ray of light passes through the mineral and is split into two rays. Effervescence occurs when reaction with hydrochloric acid causes calcite to fizz. Magnetism occurs between minerals that contain iron. Only magnetite and pyrrhotite are strongly magnetic. Iridescence resembles a play of colors, caused by the bending of light rays. Fluorescence occurs when some minerals are exposed to ultraviolet light, which causes them to glow in the dark. Each of these minerals also are being classified according to its composition. And these are the following. It includes the native elements: sulfides, halides, oxides, hydroxides, carbonates, sulfates, phosphates, borates and silicates. And that sums up everything for the mineral topic. I hope you have enjoyed and learned something from the discussion. See you on our next session. Goodbye.